In this article, we will explore the power of event-driven architecture using Apache Kafka, microservices, and Spring Boot 3.0. We will begin by understanding the fundamentals of event-driven architecture and its benefit in building a scalable and resilient system. Real-world example will be provided to help you grasp the concept of events and their role in driving the system behavior. Next, we will look into the Apache Kafka, a distributed streaming platform that forms the backbone of event-driven architecture. We will explain what Kafka is, how it works, and its key feature. Additionally, we will guide you through the process of installing Apache Kafka using Docker, ensuring a smooth setup for your development environment. Once you have a good understanding of event-driven architecture and Kafka, we will move on to implement event-driven architecture with Spring Boot 3.0 and the microservices. To illustrate the practical application of event-driven architecture, we will walk you through the implementation of flight booking application using microservices. You will gain hand-on experience in designing microservices that communicate through Kafka topics, enabling seamless event-driven interaction between different components of the application. In day-to-day life, everything is driven by events. Let's imagine you are at live music concert. The DJ, who acts as a producer in this context, creates different beats and music. These beats and music can be seen as messages. They carry the essential information about the rhythm, tempo, and other musical elements that make up the concert experience. As a member of the audience, you are the consumer of these musical messages. You receive and interact with beats and music provided by the DJ. The DJ does not wait for your response or interaction before continuing with their performance. They continue producing and sending out messages in the form of beats and musics, and you, as a consumer, react and enjoy the concert in your own way. So, what is event driven architecture? Event-driven architecture is a system design approach that involves recording events and using asynchronous messages to communicate with the system components. Event-driven architectures offer several benefits like loose coupling, where components are decoupled loosely, scalability, which means the system can handle even high volumes of events and can scale horizontally, extensibility, where new feature can be added without disrupting existing components by introducing the new event handlers. Asynchronous processing, where components proceed without waiting for immediate responses. Event sourcing and auditability, where events can be logged for historical record keeping. Fault tolerance and resilience, where failures in one component don't cascade and events can be replayed for recovery. And finally, real-time processing and reactiveness, which helps the component can react immediately to the events, enabling real-time analytics and dynamicity. What is Apache Kafka? If we can go to the Apache Kafka website, we can see the definition here. Apache Kafka is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines, streaming analytics, data integration, and mission critical applications. Kafka has several key features like publish subscribing messaging system, stream processing, high throughput and low latency, persistence, fault tolerance and replication, and distributed and scalable. We will implement event-driven architecture using Apache Kafka. I hope you are quite familiar with some of the terminologies like event, producer, consumer, cluster, and zookeeper. If not, don't worry, we will quickly have a look on it. So first one is the event, which refers to the message or unit of data that is published to the Kafka topic. Then comes into the picture what is Kafka topic. So Kafka topic is a name, feed or category to which messages are published by the producer and from which the consumer can consume those messages. So what is producer? So producer is a application that will generate the message and it will publish this message to the Kafka. And the consumer is the one who is consuming these messages. And there is something called as broker. So broker is a part of Apache Kafka cluster which is responsible for storing and managing these published messages. Apache Kafka cluster consists of multiple Kafka brokers working together to provide fault-tolerant and scalable message storage and distribution. Along with that, Zookeeper is used for managing and coordinating Kafka brokers, and it also helps in maintaining metadata and monitoring the cluster health. To enable this asynchronous communication, we implement event-driven architecture. When we receive a booking request in our booking service and generate a booking reference number, we raise an event. This event, which we call as booking created, is treated as a message and plays inside a Kafka broker. In this setup, our booking service acts as a producer of the event message while the notification service acts as a consumer. The notification service consumes the message and processes it accordingly. However, it does not handle the actual task of sending out notifications like email or SMS. Instead, it focuses on setting up and managing the event-driven architecture. We will install Apache Kafka in two ways to our local machine. First, from the official website and follow the instruction to download, install and run the Apache Kafka. The other approach is using Docker. We can use Docker and Docker Compose to create the necessary container for Kafka. So this is the official website for Confluent. From here, go to the quick start and go in the section called Docker. The first one is setup Kafka broker. So copy this docker compose.yaml file and put it in your visual editor. So this is my workspace where I have already copied this file. Let's say you are building a flight booking system and you need a way to notify your customers about important update. This is where a notification service comes in. To build this notification service, we can use a design approach called event-driven architecture. This means that we will set up our project in a specific way to handle events. In our booking service, we currently communicate with the flight service in a synchronous manner. That means when we make a request to a flight, we wait for a response from the flight before moving forward. This type of communication is called as synchronous communication. However, we can also use asynchronous communication. In this case, the booking service would make a request to the notification service, but it would not wait for a response. It would simply send the request and move on without expecting an immediate reply. This is known as asynchronous communication. Now let's try to understand about this file. So inside this YAML file, the first statement is the version 3, means we are using the third version, and we have a configuration for services. So these services we need to run two instances. The first one is the Zookeeper and the broker, as we discussed. So first one is the image. So this is the image to download the Zookeeper, and we are providing the container name as Zookeeper. Along with that, we are configuring two more properties. The first one is the port and the second one is the tick time. The tick time is nothing but a heartbeat. So this is 2000 millisecond. It is same like Eureka server, how it will send the heartbeats. Then the next detail is about the broker. So for this broker, we also need the image name. So we have defined the image name as CP Kafka and the version is 7.3.2. If you have noticed, the same version is used for Zookeeper. The next one is the container name, which is the name of container broker, and the default port for this one is 9092. So we are defining the target port as well as 9092. It has dependency on Zookeeper, so we have defined the dependency also as Zookeeper. Now let's see the environment variables. The first one is the Kafka broker ID. This we have given as a one, which is a unique identifier. The second property is a Kafka Zookeeper connect. Here we have given the name of the container and the port number as we have seen here. The container name is Zookeeper and the client port is 2181. The next property is Kafka Listener Security Protocol Map, which maps the listener names to their respective security protocol. In this case, it specifies that plaintext listener uses the plaintext security protocol and the plaintext internal listener also uses the plaintext security protocol. The next one is Kafka advertised listener. This parameter specifies the listener endpoints that Kafka advertises to the client. Here there are two listeners defined. The first one is the plaintext and another one is the plaintext internal. The plaintext listener is accessible at localhost on port 9092 and the plaintext internal listener is accessible at the hostname broker on port 29092. Kafka offsets topic replication factor 1. This parameter determines the replication factor for internal Kafka topic used to store offset commits. In this case, the replication factor is set to 1, meaning that there is only one copy of each offset stored in the Kafka cluster. The next one is Kafka transaction state log mean ISR 1. This parameter defines the minimum number of in-sync replicas, which is called as ISR, required for the transaction state log topic. The transaction state log stores the intermediate state of ongoing transactions in Kafka. This value is set to 1, which means at least one replica must be in sync to consider the log topic available. Kafka transaction state log replication factor. This value is set to 1, which is only for one replica, and it determines the replication factor for transaction state log topic. Now go to the terminal and from here launch a new terminal and make sure your docker compose.yaml where you have copied you are inside that folder. So once you are in that folder, from here type the command docker compose up -d and you can see it will try to create the images for Zookeeper and broker. Now you can verify this using the command docker -ps and you can see there are two containers. The first one is with the Kafka broker and the another one is with the Zookeeper. Now let's see the same in Docker desktop. Go to the Docker desktop and here you can see there is an instance called flight booking system has been created in the container. And once you launch this, here you can see there is a Zookeeper and there is a broker container with the same configuration what we have created with the instance 7.3.2. And also we can see in the image section both the images are created successfully, the broker image as well as the Zookeeper image. You can verify the Kafka log by typing this command docker logs-f broker and you can see here everything looks good. As now we have completed the download and installation for Apache Kafka, the next step we will do is to create a notification module and create an end-to-end flow for integrating event-driven architecture using microservices in our system. Now let's see how we will integrate Apache Kafka using Spring. Spring for Apache Kafka project applies core Spring concept to the development of Apache Kafka based messaging solution. It will provide several features like Kafka template, Kafka message listener container and the Kafka listener, Kafka transaction manager and Spring Kafka test. So we will use all these features. Kafka template we can use to produce a high level abstraction for sending messages from the producer side and we can use this annotation Kafka listener in the consumer side to consume the messages. So as we discussed, let's implement booking service for the producer. So here we will use the Kafka template and we will create a new module called notification service, and here we will add a logic for the Kafka listener. As booking service is a producer application, so let's create an event and publish this event to the Apache Kafka topic, and we will create one topic also called notification topic. So first we will create one package called event inside the booking folder, and we will create an event called booking completed event. For time being, I am just providing the booking number in this class. We can add additional detail as well. Then go to the booking service IMPL class, and here we will add the required logic. But before adding this logic, we have to add the library Spring for Apache Kafka in our application. From the Spring initializer, add the dependency called Kafka. The first one is Spring for Apache Kafka. So just click on this one and go to the Explore option, and from here you can copy this dependency, Spring Kafka related dependency, and in the pom.xml copy this dependency. Once this dependency is added, go to the booking service IMPL class, and here we can define the Kafka template. So this is how we will define the Kafka template. The Kafka template will take key and value argument. So the key will be the notification topic what we want to use, and the value will be the objects what we want to publish. So here we will publish booking completed event. So these two value we have to provide in the Kafka template. Then we have to go inside this method called create booking, which will first check for the seat availability, and it will reduce the seat for the flight by invoking the synchronous call using the flight service. And once this is successful, it will use again the synchronous call to the payment service to do the payment, and once this payment is done, we will use our event to publish the event. So here we will add the logic. So let's create the booking completed event object here by passing the booking number from the above object, and once this object is done, we will log this message. Kafka templates has several send method overloaded. We will be using this specific method which will take the topic as a string and the data. Okay, so in our case we are using the notification topic and we are using this booking completed event. I have hard coded this value for notification topic. We can make it more generic by configuring using the constant variables. Okay, and then we are printing this status. Now the next step is we have to configure some Kafka related configuration in application.properties. So go to the application.property file, and the first property is Spring Kafka Bootstrap Server. So we have to provide the broker server detail here, which is 9092 localhost. So if you go to the docker compose.yaml file, here we have defined the container name as broker and the port is 9092. So this information we have to add in the application.property file. Then the next one is the topic name. So the default topic is the notification topic, as we have mentioned here in the booking creation of this class. Along with that, we have to provide the key and value for serialization. So if you see this Kafka template, here we are using string as a key and value as a booking completed event. So let's provide as a producer this serialization details. So in the Spring Kafka producer key serializer, we have to provide here the string serializer, and for the producer with value serializer, we have to add the JSON serializer. Along with that, we have to provide the specific type of the class name. So this is very important. So inside this producer property, the JSON type mapping we have to provide. So the JSON type mapping is the name of the class what we have given. and you have to make sure that this name is fully qualified. So you can copy this detail from this booking completed event. You have to copy this entire package name followed with the class name. Now let's create a module called notification module by going to the Spring Initializer, and here provide the artifact ID as notification service, the name as notification service, packaging as jar, and use the Maven version with the Spring Boot configuration with 3.0 version, and it will use Java 17. Along with that, add some dependencies like web, Lombok, Kafka, Zipkin, and we want to use this module also as a Eureka client so that Discovery server can notify this. So let's add the Eureka client and click on the generate option. Now extract this folder and copy this folder in your main module. Once it is done, go to the Visual Studio Code, and here we can see the pom.xml file. Okay, and we will make sure that all these dependencies are available. Once this is done, here also we need to receive the event. Okay, so we will create the same booking completed event what we have created in our booking service. Now you will be thinking why we need this booking completed class two times, once in the booking service module and one in the notification module. Ideally, it is a good practice when we are using this class for sending and receiving, instead of making this as a common utility and use it, because sometimes it happens there are some changes which is happening, so it is always advisable to have their own version of the copy. Now let's go ahead with the notification service application. So here we will create the event listener called as Kafka listener. So here we will define a Kafka listener, and the topic, previously we have used the notification topic, so we have to make sure the same topic is used here. So we have to configure this property called as topics equal to notification topic, and here we will create one method called handle notification, which will receive this event called booking completed event. And here for time being I am just logging the message called got the message, and apart from this we can use here additional logic for sending out the email notification. As we have provided some key value serializer for the producer, the same thing we have to provide as a deserializer for the consumer class. So first let's create the bootstrap server localhost 9092, then the default topic. These two configurations are same. Along with that we have to add one additional property called as consumer group ID, because in Apache Kafka everything works with the group ID concept. So here we will provide the group ID as notification ID, and here instead of producer serializer we need consumer deserializer. So in the consumer deserializer, the same way we have to provide the key as a string and the value as a JSON deserializer. And for this JSON deserializer we have to provide a special type of mapping, and this mapping again is a entire path of booking completed event. We can see again the pom.xml file. So here we can see the Java version 17 is there. We can also add the Maven compiler source and target as 17, and the required details like web and all the Zipkin configuration, which is having this three dependency Kafka, Lombok, Eureka client, and the test. Along with that, this Spring test also added once we add the Kafka dependency. Now let's try to restart all our servers. So we will start all our server like API gateway, booking service, discovery server, flight server, notification server, and the payment service. Alright, now all our services are running. In the notification service, you can start watching this message for Kafka message, listener container, and other detail. So it looks like the Kafka is configured successfully. Now let's run this application using a Postman. Before running the Postman API, let's see the Eureka server. So in the Eureka server, we can see the notification service module has been created successfully with this detail. So here we have configured this port default as 0. So let me show you once more time. As we have created this module newly, so we have to add some additional detail as we have done in the previous section, like the Eureka default zone we have to provide, the application name we have to provide, and the port number. The port number equal to 0 means it can use any port at runtime irrespective of the specific port. And these are the two Zipkin configuration we have added, that is localhost 9411, and this is a sampling probability equal to 1, which means we are allowing 100% requests to be sent to the Zipkin server. I have already created a API gateway create booking API. So let's hit this one. I am already using Keycloak for security, authentication and authorization. So first let me create this token. Once this token is created, use this token and then click on the send option. Ideally, you should wait for 30 seconds because Eureka server will take some time to configure all the services. As we can see, the message booking ID has been created successfully. And we can verify the same thing in the logs. So if you go to the logs of notification service, we can see the message got message, and this is the object with the booking number. And also in the booking service application, we can see the message booking status is completed, and this is the event what we have fired, event to notification topic with event, and this is the booking number what we have created. So this booking number is 231 starting and ending with B95. If we see here, it is starting with 231 and ending with B95. So it looks fine. Now let's verify the logs in Zipkin. So click on the run query and here configure the setting for 1000 and run the query again, and here we can see the request. So the API gateway has called this booking service. So we can see the logs like this way. Thank you for watching. That's all for this video. In the next video, we can see about the Prometheus monitoring, and we can see how the observability we can use to monitor the logs.